One of the greatest challenge of large language model based application that I have faced and a headache for everybody working in this space is how to enable LLM applications to adapt to their evolving environments through real-time pipelines and process real-world data continuously. So if you are building an agent today which depend on augmented generation like RAG augmented generation, where the data is external or non-parametric and the model needs to see updated information all the time because let's say the document under the hood that the application is using for its knowledge base are changing. Or if you're someone building a chat application where new chat messages are coming all the time and the agent or the model needs to know about what is happening, then you need an index or a set of indexes that are continuously updated. So the challenge is after my set of documents get embedded and put into a vector store like Quadrant or Weaviate, how do I reindex? How do I add a new capability into my pipeline? Or how to keep the whole system online, keep the indexes online while reindexing and so on. So we need a solution to build production-grade LLM applications that react to your data. And this external data is no more single modality because we are entering into a world where multi-modality is a norm. Like documents, videos, audios, all these forms are super important to the workflow. So you need the capability to ingest any kind of data and then build indexes out of them. You also need a scalable compute engine so that whatever new data comes in, you are able to index them appropriately and update the indexes and so on. To deal with all of that, introducing you to a new tool that's very recently launched, TensorLake's open source real-time data framework Indexify. And my initial usage looks absolutely great. So the first question you will ask is that how Indexify fits into your LLM application. Well, Indexify sits between data sources and your application. It will keep ingesting new data, run pipelines, and keep your database updated. LLM application can query the databases whenever they need to. So a typical LLM application workflow looks something like this, that you upload unstructured data, for example, documents, videos, images, audio, to pipelines. So Indexify pipelines then automatically extracts the information and updates vector indexes and structured stores. And then you want to retrieve information via semantic search or vector indexes and SQL queries on those structured data tables that Indexify has built for you, taking the content. Now, Indexify enables you to do all of these and create a reliable pipeline capable of handling thousands of documents per second. So Indexify is basically a long-running service like any other microservice running in your environment and exposes an API for uploading any form of structured data. So with Indexify, after you upload a bunch of extractors run in parallel on the cluster and extract information out of these unstructured data, that is the content that you have uploaded, then update indexes on something like Quadrant Vector Store or Postgres data warehouse for semi-structured data continuously. And also another point about cost saving with Indexify. You all know that bandwidth is not cheap on the cloud. GPUs are expensive. Nice thing about Indexify is that we can co-locate data plane processing unstructured data closer to where data is stored. This is a huge advantage because bulk of the bandwidth goes into ingestion for unstructured data. So being able to process data in the same neighborhood where they are temporarily stored saves you money. So you can install this package, pip install Indexify LangChain for working with LangChain. And also similarly, Indexify complements DSPY as well. And here as well, install the Indexify DSPY retriever package, that is pip install Indexify DSPY. And for downloading Indexify, just move over to this particular tab in the documentation. You can use curl or you can use Docker. and also their GitHub release. And extractor CLI and SDKs that are also available. So it's super easy to get started on your local machine. Now, one important thing to remember, Indexify is open source. So the entire code is available to you in their GitHub, and you can change it, inspect it, and customize it to your requirement. Now, extractor is the building block of Indexify. So let's understand what is an extractor. So a typical workflow using Indexify involves uploading unstructured data, that is documents, videos, images, or audio, wait for vector indexes or structured stores to be updated as extractors are applied on those initial content, and as indexes are updated continuously, you could retrieve updated information from them via semantic search on the vector indexes and SQL queries from structured data tables. So the extractor is a Python class that can transform unstructured data into intermediate forms. For example, a PDF document transformed into text, images, structured data if it contains tabular data, and extract features like embedding or metadata that goes into various indexes that can be retrieved by your LLM application. And transformation is done by returning a list of content objects from an extractor. Example, ingesting a video content and returning the audio from the video, or ingesting a PDF and returning chunks of text from the PDF, or ingesting an audio and segmenting it by voice activity detection such that it's chunked by pauses in speech. An extractor can enrich an ingested content by adding structured data to the content. For example, adding bounding boxes of detected objects and their labels to an ingested image. And here is a cool thing. Structured data returned as metadata in Indexify, and all the keys of the metadata become queryable using SQL queries. So with Indexify, you basically get all of that in a single application, in a single binary, which is distributed on your cluster. You wouldn't have any external dependencies other than the storage systems, essentially to have a very scalable data infrastructure for your RAG application, that is retrieval augmented generation applications, or for your LLM agents. So what can you do with Indexify right today? You can create pipeline to parse, summarize, embed, classify, and detect entities in videos, images, and documents, ideal for environments where data constantly evolves and LLMs make crucial decisions on the latest information. So let's quickly talk about some of the things that Indexify will give you right now in more detail. Number one, real-time processing. Optimized for tasks like summarization, extraction, embedding, and parsing, Indexify excels with frequently updated data. It can ingest any data modality at scale with incremental updates that don't require reprocessing the entire documents. Indexify is designed for real-time performance. The reactive engine starts execution in less than 5 milliseconds. And near instant execution means that your LLM will know about the changes in a document or uptake transcripts from a sales call as they happen. The compute engine is built on top of a replicated state machine, which allowed them to develop a fault-tolerant control plane without the overheads of polling a database like Postgres or Redis to react to new data. And the next point is about reliability, multi-cloud, and hardware acceleration. So Indexify reliably processes data even during transient infrastructure failures, ensuring high availability. Extracted data is automatically stored in storage systems, and pipelines can run on GPUs, CPUs, and across multiple clouds for flexibility and resilience. And also it is fully observable using open telemetry. Indexify lets you pinpoint bottlenecks in an extraction pipeline and retrieval APIs for semantic searches and SQL queries. And if you're thinking about whether it is ready for production use case, Well, Indexify has been rigorously tested on AWS with hundreds of thousands of documents and images to ensure it's ready for production, and also integrates with all of your favorite databases. So Indexify integrates with Quadrant, Pinecone, pgvector, and LansDB for vector storage. They use blob store to store the raw unstructured data instead of vector stores to allow for scalable reads and writes of large files. And Indexify supports Postgres and SQLite, the most popular structured data storage systems, and additional storage backend support is very much coming soon. So looking at their site, you can see you can build a basic RAG with Indexify. You can also build a video RAG. That's quite interesting, isn't it? So with video RAG, you can do keyframe extraction, audio extraction from videos, tracking objects in videos. And one thing I wanted to particularly point out, its relationship with LangChain. So how Indexify is different or how it is similar to LangChain. So Indexify complements LangChain by providing a robust ingestion engine for indexing large volume of multimodal content such as PDFs, raw text, audio, and video. It provides a LangChain retriever to retrieve context for LLMs. All right, now I'm looking at their documentation, and this particular page talks about architecture. For example, it says support ingesting millions of unstructured data and continuously running extraction and indexing pipeline in real time. Horizontally scale with more ingested data, so applications don't need to switch to a more serious framework as they become mature. Yeah, just definitely go through it. There's lots of important information here. And overall, the documentation is very, very well structured. Lots of information, lots of examples, and very well written. So let's go to this section, key concepts, because that's kind of where you will start. Extraction graph. This is where everything starts from. So the what is these extraction graphs are multi-step workflows created by chaining multiple extractors together. They allow you to manage and orchestrate complex data processing pipelines by applying a sequence of extractors on ingested content, tracking lineage of transformed content and extracted features, and enabling deletions of all transformed content and features when sources are deleted. And let's just dive deep into the extractor section here. So extractors are used for structured extraction from unstructured data of any modality. For example, line items of an invoice as JSON, objects in a video, embedding of text in a PDF, etc. And we'll see in a second example of these. That is how to deal with PDFs with Indexify. And that's where the first step will definitely be this extractor section. And extractors consume content which contains raw bytes of unstructured data, and they produce a list of content and features from them. So basically, this is the workflow with extractors. You have your content that is coming, that may be your PDF, videos, any form of text, audio, etc. That is completely multimodal content that goes through extractor. And then you have your content embedding and metadata extracted by the extractor. And for the installing of the SDK, you have the tools to build, test, and package extractors are available through this Python package, Indexify Extractor SDK. And you can run extractor locally. That is, there is an example command here, right here. So you can run the extractor as a long-running process to continuously receive stream of content and then extract them from the Indexify a control plane. You can run as many instances of the extractors you want and achieve scalability. So this is an example command for that, and it is using the local host and with the port specification. And also you can use Docker. That is, extractors can be deployed in production with ease using Docker along with Indexify server in a cluster. You can test an extractor package with Docker by running the Docker locally. And this is the command for that. And what's more, you can actually develop your own custom extractor. So that's where I'm looking at. That is under these develop extractor section. So custom extractors allows you to plug in any data processing code you want into an Indexify pipeline. Example, custom chunking algorithms of your data or using your own model in a pipeline. And the concept here is that an extractor receives unstructured data in content object and transforms the content into one of many content. Yeah, we already discussed this. And the content object has the following properties: data, content type, feature. And yeah, for that you have to install obviously the Indexify extractor SDK. And then this is an example command for doing exactly that. That is when you are creating a template for a new extractor in your existing directory. And remember again, these content object, this one right here. So content object which have the byte of unstructured data and the MIME type. So you can pass a list of JSON, text, video, audio, and documents into the extract method. It should return a list of transformed or derived content or a list of features. Example, text chunking, audio transcription, speaker diarization, PDF extraction, PDF to markdown, etc. So let's quickly go through these very basic example of the entire pipeline of using Indexify. So here in this guide, they will walk through creating an online ingestion pipeline for Wikipedia pages, and this pipeline will demonstrate how to extract the structured information, that is NER or named entity recognition, and then break down the text, create embedding, and store them in vector databases. So by the end of this, you will get to know a couple of points from here. Use advanced LLMs like GPT-4 or Mistral to answer question based on indexed information, and retrieve the named entities extracted from the text, and use a user interface to visually debug your pipelines and inspect how pages are broken. So you have to have 3 terminal opens here. Terminal 1 for downloading and running the Indexify server, Terminal 2 for running Indexify extractors, and Terminal 3 is for running the Python scripts to load and query data from the Indexify server. So this is the overall workflow in the 3 terminals that you will have open. The first one, ingestion of API user interface. The second one is for installing the dependencies, download extractors, and set up the workers. Terminal 3 is for ingestion and query. Now going back, also understand the Indexify component. You have an Indexify server, which is a central coordinator and data ingestion API. Then you have extractors, and then finally the extraction graph, which is a declarative YAML file that chains together extractors into a complex pipeline. So step 1, setting up the Indexify server. When you run this command creates 2 important endpoints. The first one is ingestion pipeline, and the second one is the user interface. And obviously the ingestion API is used for uploading content and retrieving data from indexes and SQL tables, while the user interface provides a dashboard for visualizing extraction graphs, contained indexes, etc. And then creating the virtual environment, you want to run this entire thing in your own custom VNV, and also install all these dependencies: Indexify extractor SDK, Indexify, Wikipedia, OpenAI. And here, remember, Indexify is a completely open source library, as I have mentioned earlier. You can just go to their this repository in GitHub and get access to the entire code here, right? All right, now moving forward, after you have installed all these dependencies, next step is to get your extractors. Now this is the workflow again. Raw content comes to the extractor, and from the extractor you get a list of content and embedding. That is basically your unstructured data of text, audio, video, etc. becomes structured. Now extractors consume content which consists of raw bytes of unstructured data, and then produce a list of processed content along with extracted feature. And just like I mentioned earlier, that you can have your own custom extractor. So this code right here is just an example of that. We are not using this in this workflow, but this is just an example that custom extractors can be written by implementing Python class that extends the extractor abstractor class from Indexify extractor SDK package. And here you can see that these new named extractor is created, and then it will chunk the documents or whatever is coming in as content, and then finally give you an output of structured data. But in this case here, this is not using that extractor because they already have extractors that are written, deployed, and tested. So first thing, you mention or export your OpenAI API key, and then download 3 essential extractors. Those are you download with this command, that is Indexify extractor, download, and mention your extractor name. And after you have downloaded all your extractors, then let's start all the available extractor by running this particular command, Indexify extractor join server. And then step 4, which is defining your data pipeline. So here you define your data pipeline using a YAML file to process text documents by splitting them into chunks, extracting entities, and embedding the chunks in parallel. This particular diagram outlines the Indexify end-to-end pipeline. And so let us create this particular YAML file. This is YAML named as graph.yml. So you name your file here, and then extraction policies. This is where you define all the configuration. Name, input params. Within input params, you have your entire system prompt. That is here, what's the system prompt? Extract entities from text and return the output in JSON format. And then also you mention your chunk size, overlap, extractor name, etc. And this YAML file defines 3 extraction policies, which is entity extractor, that is the extracts named entities from the text, and then chunker and wiki embedding. And about the 3 extractors that we used, these are those ones. That is, OpenAI extractor uses OpenAI's LLMs for entity extraction from various input types. Text, PDF, images, it can be customized with specific system and user prompts to tailor its output. Then you have chunk extractor and mini LLM extractor, which generates embeddings of the text chunks for semantic search and retrieval. Again, these extractors were already pre-built and tested. This is not a custom extractor. This was already there. We just downloaded them. And just want to repeat again that Indexify pipelines operate in real time. That means all these extractors that you just extracted and used, they process data immediately after ingestion. This makes them ideal for interactive applications and low latency scenarios. All right, next step is creating the extraction graph. These are multi-step workflows created by chaining multiple extractors together. They allow you to manage and orchestrate complex data processing pipeline by applying a sequence of extractors on the ingested content and then tracking lineage of transformed content and extracted features, also enabling deletion of all transformed content and features when sources are deleted. And you create the extraction graph by first importing the necessary module, which is this line right here. And then this is the method with which your actual extraction graph is created. And after your extraction graph is created, the next and obvious step is loading your content, that is your data, all the unstructured data. That could be anything, any modality. And here we are using LangChain community package and also the Wikipedia loader. And that's used to load your Wikipedia related stuff here. So as you can see in the code, the docs is an object coming from Wikipedia loader. And then we run this particular line for doc in docs, client.add document, wiki extraction pipeline, and doc.page content. And then we have 2 separate strings for doing my queries, Kevin Durant and Stephen Curry. And the final step is actual query, and you can run query on Indexify to list ingested content by extraction graph, or get extracted data from any of the extraction policies of an extraction graph, or perform semantic search on vector indexes, or run SQL queries on structured data. Now here you have to mention your OpenAI API key, and then this set of code will actually set you up for running the query. And these are just few simple step-by-step lines. There is no complexity at all here. So first you get your entities, That is, you get your content ID, and then from those content ID, you get the two things, wiki extraction pipeline and entity extractor. Then get your chunks. Also define a Python method to actually set all this configuration. That is all your OpenAI API compliant stuff, like your response will be client.openai.chat.completions.create. Set up your message, content, etc. And of course, the model that you are using here. And let's just dive deep into the extractor section here. So extractors are used for structured extraction from unstructured data of any modality. For example, line items of an invoice as JSON, objects in a video, embedding of text in a PDF, etc. And we'll see in a second example of these. That is how to deal with PDFs with Indexify. And that's where the first step will definitely be this extractor section. And extractors consume content which contains raw bytes of unstructured data, and they produce a list of content and features from them. And then finally, here are my two queries. What accomplishment did Kevin Durant achieve during his career? And also mentioning the two extractor, wiki extraction pipeline wiki embedding. And then this is your final response. That is, you should see a response summarizing Kevin Durant's career accomplishment based on the indexed Wikipedia data. And here, if you are wondering where I got this thing from, that is wiki extraction pipeline. Remember, we set up a YAML file. There we mentioned it. Yep. So when defining our data pipeline, we defined this graph.yml file. There, the name was this wiki extraction pipeline. So this was a basic example that I took right from their documentation right here. You can also see an intermediate example by clicking here. And now I'm just going to check out another thing from their GitHub repository. So this is the Indexify official repository. If you just go into the example section under the examples, LLM integration, you will find actually a lot of examples here. You can just go and check them out one by one. It will be great for learning and get used to Indexify. And right now, I'm just going to look at a very common example using GPT-4o to translate from one language to another with Indexify. So this is a notebook. This cookbook demonstrates how to build a robust PDF translation pipeline from English to French using Indexify and OpenAI's GPT-4 model. You will learn how to efficiently translate PDF documents for various applications such as multilingual document processing, content localization, and cross-language informal retrieval. So here again, of course, you need the Indexify package, and that's mentioned under the prerequisites. So you need to run this command to install Indexify. And then initially defining these YAML that we also defined earlier, that is creating an extraction graph. And this is where you create and define your client, which is an instance of Indexify client. And then like earlier, we give a name to the extraction graph and also specify all the specification. For example, extraction policies, the specific extractor that we are using here, input parameters, there goes a model name, your OpenAI API key, and system prompt. So here the system prompt is translate the content of the following PDF from English to French, maintain the original formatting and structure as much as possible, provide the translation in plain text format. And then only these few lines of code, very simple two methods, are doing all the heavy lifting in the entire workflow. So the first method is just using the request module of Python to read from an URL, and then the translate PDF. This is where you are using Indexify. That is, first you are creating the client, which is an instance of Indexify client class. And then you need to upload the PDF, that is get a content ID. And that you are doing with this line client.upload file and passing the PDF translator and the PDF path. PDF path is again a constant that has been defined here in the next cell. And then you need to wait for the translation to complete. That is, you are running client.wait for extraction, passing it the content ID. And then finally, you are getting your translated content right here. So this is your structured content that has gone through the extractor of Indexify. And now you have the structured output from that extraction. And that's pretty much it. Oh, of course, you have to decode just like you do for any language model when you get your output. That is translated content, then take 0 content.decode and pass UTF-8. And then that's what you return from this method. And then that's it. These two methods are defined in the next cell. You are just executing that while specifying your actual PDF and also your PDF path. And then when you run these download PDF, that download PDF method will download from these URL, and then you run your translate PDF, that is this method that will translate the entire content of that PDF to your specified language. So here we were translating from English to French, right? English to French here. And yeah, so that's as easy as this. With Indexify, you just translated the entire content, and this can be integrated with your system. Remember again, Indexify is will do the extraction live. That is, the latency will be extremely low. So any system where you almost need to be online, absolutely live, there it will work absolutely great. And just to mention here again that they have many examples. So when you go to this examples directory in the GitHub repo, you find so many different implementations. So for example, the one that we just saw, that comes within this section, LLM integration, but you can also check out PDF, images, getting started, video, transcript, etc. So for example, this one is from video transcript. It is for uploading and retrieving .py. I have not gone through the code entirely, but looks like this is what it's doing. You give an entire YouTube URL, and then it will summarize or do some retrieval job on that URL or from that YouTube video entirely. Because Indexify is multimodal, so your video data also will be just treated as an content and passed through the extractor, and will be extracted properly and will give you the result within no time. Alright, now to summarize all the really beautiful features that Indexify will give you. Number 1, makes unstructured data queryable with SQL and semantic search. Number 2 is real-time extraction engine to keep indexes automatically updated as new data is ingested. Number 3 is create extraction graph to create multi-step workflows for data transformation, embedding, and structured extraction. Number 4 is incremental extraction and selective deletion when content is deleted or updated. And the extractor SDK that you will install with Indexify allows you to add new extraction capabilities and many readily available extractors for PDFs, images, and video indexing and extraction. Number 6 is Indexify is multi-tenant from the ground up. That is, namespaces to isolate sensitive data, works with any LLM framework including LangChain, DSPY, Llama Index, etc. Runs on your laptop during prototyping and also scales to thousands of machines on the cloud, and works with many blob stores, vector stores, and structured databases. They also have an open-sourced automation to deploy to Kubernetes in production. So definitely check it out. It looks super interesting for me.